Previously on Retro Hack Shack.
In a previous episode over on my main channel, I got to take a look at some TRS-80 Model 1 equipment, and one of the power supplies had been hacked up by a Dremel tool. Now, while this power supply was working, there's no way I was going to let anybody use it in this condition. So I decided to make a reproduction power supply case. So if you've ever wanted to make a reproduction case of some vintage computer hardware, this is your chance to follow along and see some of my techniques, both new and old, for making reproduction cases for vintage equipment. That's coming up right now on Retro Hack Shack After Hours. Well, hey everybody, welcome back to Retro Hack Shack After Hours. My name's Aaron. Thanks for joining me on this journey today to reproduce this case. Now, I did have another power supply here that was intact, and that's a good thing because I'm going to need to take some measurements in just a second. But let's just take a look at this case for a second. I can already tell there's going to be some challenges here because this isn't just a straight-sided box. In fact, the sides of the box are all angled a bit, starting from the bottom and working their way up to the top of the case. In addition to that, there's this kind of a plate feature on top of the case here. Now, this is all one piece of plastic, but this little additional feature up top that doesn't align with the sides of the cases is going to cause some problems as well. Not only that, but there's relief around the text, the Radio Shack, the TRS-80, the power supply. There's all of this little relief area, and that is a separate color, of course, from the rest of the case. In addition, there has to be some way to allow the cables to come out that are connected inside the case to come out and be plugged into the mains power and, of course, the TRS-80 Model 1. So I'm going to have to think about a way to design a feature to allow those cables to come out without easily being pulled out completely and disconnecting the wires from the inside of the power supply. So I knew that I wanted to try to 3D print this case, but before I could do that, I had to take some really good measurements. And so I busted out my digital calipers. These calipers are an essential tool really for figuring out dimensions of an existing part or case like this. Sometimes these cases were designed in inches, sometimes they were designed in millimeters, especially given the age here. It's hard to tell which one they used originally. The nice thing about digital calipers is you can easily switch back and forth between millimeters and inches, and sometimes you get lucky and you can find some nice round figures to work with. But that was not the case here. I'm not exactly sure what they were doing, but yeah, nothing came out as a nice even round number. The next step was to get this into a CAD tool, and here I'm using Autodesk Fusion 360. The nice thing about these tools is you start with a 2D sketch and then you can extrude or pull or push the 2D sketch into a 3D model, and you can create more sketches, you can round off the corners, and it just works great. And you can see here that pretty quickly I had a pretty good reproduction of the case. Of course, it took a lot more measurements and going back and forth to make sure things were just right. Here I'm actually adjusting the corners of the case, the inside of the case, so that when you press the top part of the case down on it, that it locks into place. And once I had that done, here's how it looks from different angles. I even have this little cutout area inside here that actually is part of the original case. It actually makes it a little bit taller inside in order to allow the case to be as small as possible by having a little extra room to fit the PCB board and the transformer that's inside the case in there nice and neat and tight. And here we go. Here's a little circle around the case. I think it looks pretty good. So I exported this design and printed it out on my 3D printer, and before long I had several pieces and parts to test out to see if they would actually work. Okay, so at this point I've got my case kind of ready to go here. It looks like it's going to fit. I'm going to test that out. But along the way, I wanted to figure out how I could print the top here to get it to look like the original power supply, which is over here. It has Radio Shack, TRS-80, and power supply, and then all around the edges and in the middle here, it's silver. And I want to replicate that look so that it looks as close as possible to the original. So because I'm having a little bit of fun here, I thought it would be interesting to try some different things to make that happen. So the first thing I tried to do was just use 3D printing to make this work. And it didn't come out terrible, but it didn't come out great either. You have to understand that when printing a box like this, where the opening needs to be pointed up because you're doing layers from the bottom and then working your way up. So the opening of the case has to be pointed up. So this side is actually facing down as it's printing. And so the problem is, because this is a relief back here, when it's facing down and it's trying to print where there's nothing actually touching the plate, the 3D filament just kind of falls through and creates a bunch of mess around the letters here. So what I did was I printed with supports, and you can see that process here. And the supports worked okay. They're supposed to be easy to remove, but because this is so shallow, the relief is so shallow, it really had a hard time. And I used screwdrivers and stuff to try to get this off, and it just came out looking kind of crappy, and it fills in like the O in Radio Shack, and you can't get that out. Same thing down here with power supply. You can't get it out from between the letters. So anyway, this process looked like it wasn't really going to work that well. By the way, if you don't have a 3D printer, but you'd still like to get a project like this done, you can turn to the sponsor of today's episode, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. So then what I said was, aha, I can actually do this using the laser cutter down at the Makerspace. So we have a pretty nice laser cutter, even though it's a cheap Chinese one. It has a very large print area, and it does work quite well. So the first thing I did was I went down to the Makerspace, and I needed to see if I could actually print anything in this PLA plastic. Now, it's very important. This is PLA plastic, not ABS or anything else. It's not PET. Some of those plastics, when you run them through the laser, they will off-gas some pretty bad fumes that can be toxic. So it's important to know what plastic you're working with. So huge warning there if you wanted to try this yourself. PLA should be safe, and it shouldn't have too many toxic chemicals because it's basically made out of corn. So what I wanted to do was try to see if I could even etch anything into this. So I put a little logo in, and here are the results. So hopefully you can see this. There's different grades of speed of the laser as well as power of the laser. And I started this, I think, over here with really, really fast and really low power, and then worked my way up until I could actually see the Radio Shack logo. And this one is hard to see at any angle, but the other ones you can kind of see, and I can almost feel it with my fingers. And then that wasn't deep enough, so I did another pass over here where I increasingly went a little bit slower, a little bit stronger, until I got the depth that I wanted. And as you can see, this one to me looked the most like the actual case. And so I went ahead back since I was there. I'm like, how am I going to remember this? Well, I said, I got a laser here, so I'll just go back and put the specs in. So you can see this one is set to power 20 and speed 20. So that's 20 millimeters per second. And then, power 20 as a percentage of the full power of the laser. So that's what worked for me. Your settings may vary, but you can see getting pretty good results there. This one went through the top two layers and so started cutting into the infill. But anyway, that one was a little bit too deep. I think this one looks perfect. And here's the final result. I think it actually came out pretty well. This was a test, of course. I didn't print the whole case just yet. I just wanted to test this out. But yeah, I think it actually came out pretty good. And if I hold this top part up to be equal with the real case, you can see how well it came out. I think it's pretty accurate, and I think it'll come out really well. But now the problem is, how do I get the silver color on this piece so that it actually looks exactly like this one? So there's several methods I want to try. So the first one I wanted to try is just using either a paint marker like these back here. These paint markers are great they're permanent if you let them cure. That's very important to let them cure, otherwise they come off. But yeah, they're oil-based, they're permanent, they mark up plastic really well. In fact, you can see here, this is a Atari joystick, and it says down here, clean contacts, so this one isn't working at the moment. But I did this one, and it worked out pretty well. I did not, however, wait for it to cure, and where my thumb typically would sit over here is now, it wore off because I started using this too soon. So let's try this silver marker. I'm not looking for exact color matching right now. I just want to see if something like this is even going to work on this plastic. These do dry out, so they typically ship with them wrapped up in plastic like this, and they're very much like a spray paint can in terms of the fact that there's a ball on the inside. And you really do have to shake them up for quite a bit, just like you would with a spray can. Okay, this is looking pretty good. And by the way, I wouldn't use a brush on something like this because it's going to be impossible to brush these letters in here without the paint running down and filling up the letters. And, you know, it's just not going to look good. So, but these markers I found, you can actually get really good precision on these, and you can build them up in layers if you want. The trick to these is you have to press down first. I think there's like a little thing that pierces on the inside, but pressing down like this actually gets the paint to start flowing. I can see it now working its way down to the tip here. So let's see. Yep, there we go. Look at that. That actually looks pretty good on 3D printed surfaces. So let me just do part of this. I'll try to do the smaller letters, and let's see how this works. See how it comes out. Now, while that dries, the other thing I wanted to try just for fun is these silver Sharpies. These are not the paint kind. So if you get the ones with the fine tip, they also have this kind of similar mechanism here with actual paint inside of them. But you can find the slightly fatter ones. I think they're still called thin on when you look them up on the internet. But you can get these slightly fatter ones. And I use these all the time to mark chips, ICs, and other things, boards, because you can see the silver really well. So I wanted to compare the paint marker with just a standard Sharpie, see what that looks like. All right, well, here's the results. So this part up here was where I started to do the Sharpie, but as you can see, it's very faint. And, you know, if I leave the Sharpie open for more than a few seconds, the tip dries up and I have to put the cap on and wait for the end to saturate again with the Sharpie stuff. So that doesn't look that good. But here's the result of the paint pen, the silver paint pen, and that came out really, really well. I did half of it because I thought I could do half with the Sharpie, but yeah, that didn't work. So it looks really well. You can see down here in the power supply area, I wasn't careful enough, and I ended up getting, like next to this L down here, I ended up getting a little bit of the paint down there. So you do need to be pretty careful. But I think if I took my time with those small letters, I think this might work out really well. All right, well, here's the results with the paint pen. It actually looks pretty good, I think, side by side. Again, I think if you take your time, it'll come out really well. And in the little places around the letters where I pressed a little too hard or I got in the cracks there, you could come back with a black marker or little dab of black paint if you're really careful and cover up that silver area. So yeah, I'm actually, in terms of ease and quickness to get this done, this was a pretty good way to do it, I think. What do you think? Is this pretty close or what? So the next method I thought I would try is using an embossing technique. This came to me from my daughter, who's an artist, and I was telling her about what I was trying to do, and she said, "Dad, you should take a look at this embossing powder." But since I haven't done this before, I thought I would try just with a regular stamp. This is a stamp of a whale, and I've cleaned it off on the other side. So I'm just going to put it on there and then press it down carefully onto the paper. Hopefully that's all I need to do. And then I'm just going to just pour this really fine embossing powder over wherever I put that. I'm not exactly sure where it is. Somewhere over here. Take that off. No, I can't see it very well. Oh yeah, that's much better. Now you can actually see the outline of the whale. Looks like there was a little bit of that powder that I got on here, but I think I can just kind of take that off. Okay, so now if I had done this maybe a little bit better, I'd have a nice outline. And now you're supposed to be able to just take a heat gun and melt that embossing powder. Yeah, that dried really nice. It doesn't stick out too much. It doesn't stick out like, millimeters above the page or anything, but it does work. And it came out actually really well. So this may be something to try, at least if not, for this project, maybe for something else. So let's give it a try with the actual top of the case now. So I think what I'm going to do is just put a coating of this stuff down, light coating on the paper on this side. And then here we go. I'm going to try this, put it in the embossing ink stamp thing, take it out and put it in the powder. Probably shouldn't have dropped it like that. Oh no! Oh no! This did not work. It did not work. So it would have worked, you can see, but it got in the crevices here. Might be able to take a brush and brush that out. Let me try. Well, and there's what that looks like. So that was an experiment, but a failed experiment. So not only did the embossing powder not stick where I needed it to stick, but also the heat of the heat gun, which I probably could have controlled better. I only had it on there for a few seconds, but it was hot enough to get the plastic to melt. So you can see it's bent there, hopefully. And yeah, it's kind of like concave now. Okay, there's one other technique I want to try, and that is to go ahead and paint the top surface before I laser etch it. Paint the whole thing, let the paint cure, and then go ahead and laser etch the pattern out, cutting out the painted layer along with the plastic layer underneath as it goes. So I thought I would try that, and I've got two paints here. I didn't know exactly what they would look like, so I just kind of ordered them the closest things I could find. These are from Folk Art. This one is metallic, but it says silver sterling, and that's a lighter color. This one is slightly darker and maybe more reflective. This one is called Platinum, and it has, at least by the sticker, it's much more shiny and a little bit darker. So I'm hoping that this is a good indication of the color, because actually this gray color here matches the gray color on the existing power supply. So what I'm going to do is I'm going to try this one, paint the top here, and then I'll take it into the makerspace and laser etch the pattern on top of that. So it actually came out pretty well. I put 2 layers of acrylic paint on this, and 1 hour in between each coat, and then I let it dry overnight. And it was still a little tacky when I took it down, and that's a big part of why this doesn't look quite right. You can see, for example, the power supply letters look less silver, and you can barely see that they're shining out or differentiated from the black background. So the problem here is when the laser ablates or vaporizes the material, it can kick up some kind of powder or dust as it does so. And because the paint is still a little bit tacky, especially near these really thin letters, that material just stuck to the paint. You can see it did fine here on the edges and around the TRS-80. Didn't seem to bother that, but I can't even knock this off with my finger. In fact, I'd probably just take the paint off with it, because the material just kind of stuck as it was ablating from the surface here. So unfortunately, this could work if I could find a way to have either a more dry or solid paint surface before I did the laser engraving, where I could actually brush off that dust. Or what I typically do, what I found is that with the, let's see, do I have another one? Like with this one, what I would do with this, you can still see that dust there around the letters. And what I would typically do is either use water or a little bit of IPA alcohol, rubbing alcohol, essentially, to get in there and clean up those surfaces, maybe with a toothbrush. And then it would look, the whole thing would look a lot darker in general, and because of that, powder would be gone. So here I've ranked these from best to worst. This is the original. This is the paint pen, which actually I think worked out the best, and you can do multiple coats if you want to really make that stand out. But you do have to be a little bit careful, obviously, so you don't end up getting paint down on the lower relief areas here. This is the paint and then laser method. You paint the surface and then laser down. That's probably my second preference, still not great. And of course, the worst one is the embossing. This method, at least in this case with these materials, isn't going to work. So my recommendation after all these tests is just to go ahead and buy one of those paint pens. They're not very expensive and the results look great. Now it was time to take the transformer out of the old case and do a test fit in the new case. In order to do that, I had to desolder all of these wires, remembering where they all go. The biggest barrier to making this transformer fit isn't the transformer itself, but rather actually this fuse. It's pretty big and bulky and it could easily get in the way. So I'm going to desolder that as well and replace that with something else. But more on that in just a second. With the fuse out of the way, the top of the case fit on the bottom part very securely because of those little tabs that I added down there in the corner. So this thing isn't going to come apart, but if I do want to take it apart, I can do that with a screwdriver or probably even my fingernails if I got them in the right angle. Now, before I pass the wires through, I wanted to add some grommets around these holes here that I created specifically for the grommets, making sure that the width and the inner and outer diameters matched exactly with the grommets I was going to use. Even though this is a plastic case instead of a metal one, there still could be quite a lot of rubbing and friction here around these holes for the wires, so by using grommets, they will be protected for a long time to come. I just happen to have some of these smaller 2-amp fuses, which matches the 2-amp fuse that was in here before. These are rated up to 350 volts, and they will allow me to close the case properly without having to worry about all of that big manual bulk of the fuse holder that was in here before. And remember, because this case is removable, if the fuse ever does blow, I can always open it up and change this out at a later date. Because I've been manhandling this transformer with its associated DC conversion board here, I wanted to check the voltages once I got everything wired up and before I closed the case, just to make sure everything was actually reading the correct voltages like they were before. Unfortunately, my camera quit just as I was recording this particular section, but you'll have to take my word for it, the power supply is working at the correct voltage levels. Last but not least, I wanted to add a little strain relief, if you will, or pull-out protection, and so I added these zip ties to the cords so that they wouldn't pull out through the grommets. I also took the time to do a little bit of finish sanding on the case to get rid of some of those vertical ridges that appear whenever you 3D print something on an FDM printer like I use. There we go, it's on nice and tight, and now we have the brand new reconstructed power supply. And move this out of the way, here is the original power supply. So hopefully you can see they're not identical, but they're very, very, very close. Like I said, I measured everything exactly to spec for this one. So yeah, they look pretty good. The only thing I can see is I got my, in the little dash in between the TRS-80 here, it looks like the paint got in there when I was painting this part. But I think it looks really good. This paint is a little bit more reflective. I went over it with 2 coats. But all in all, I would say it was a job well done and a very fun project. I learned a lot about laser cutting plastic, 3D printing, doing this lettering, figuring out which way to put this paint on was best. So I know I learned a lot. I hope you did too. I think the last thing is just to hook this up to a good known working TRS-80 Model 1 and we'll see if it's working correctly. Okay, and one last thing I didn't realize till I was looking at the original power supply, but it has little feet on the bottom. So I found some matching feet, and so I put those 4 little feet on the bottom, and it does stay really well now. Of course, those feet are nice and fresh. They don't have dust on or anything, but yeah, that does stay in place really nicely. So I've got everything hooked up. I'm going to plug in the power supply. Look out for smoke. So all we need to do is hit the power and see if this thing is working for real. Yep, mem size. Hit enter, and there we go. We're ready to type in some basic programs. So this power supply was always working, but it's still working now that I've squeezed everything inside the case, so that's good validation for me anyway. So I'm going to keep using this one. I may need to change out the plug for a regular 5-pin DIN because this one was kind of mashed up, but that's pretty easy to do. So yeah, looks like this Reproduction power supply box is working great. If you want to get my files, my 3D printer files, I will put those in a link below in the description so you can download those. And then of course, if you can find a laser cutter, you can cut out this relief here and then use a pen to make it look almost as good as new. So I'm going to put a link up above if you want to take a look at some upcoming videos, and thanks to all my patrons for supporting the channel, and thanks to all of you who have subscribed to Retro Hack Shack After Hours. We'll see you next time. Bye.
End of line.